One of the biggest misconceptions is that the Earth travels around the Sun in a circular orbit, or the Moon travels around the Earth in a circular orbit. We think a lot of times that the planets go in circular orbits around the Sun, or that heavenly bodies move in circular orbits, and that's not the case. They're elliptical. They're elliptical orbits, and that is one of the reasons that these equations may not seem practical and they seem kind of random, but these equations are vital to bringing astronauts home, getting astronauts into space, tracking satellites, because when things go around the Earth, what it does, there's a fixed point, we'll call that E for Earth. There will be a fixed point, and if Earth is one of the two foci, with the other foci being another point that's out somewhere and it's not an actual physical object, but with Earth being one of the two foci, then it's going to swing around and go kind of long that way. That was almost circular. It was actually supposed to be an ellipse. Let's try this again. Okay, so it's going to go out a little bit like that. And so it's an ellipse, obviously. Now, they're not always this pronounced. Some are more pronounced than others. Some have highly irregular orbits and some don't. There are all kinds of different orbits. There are, and this is really neat, of the primary, the largest moons of Jupiter, the 4 Galilean moons that were discovered by Galileo, they have orbits that are relatively synchronous to one another. And what that means is, like, one of them will orbit 4 times while the other one orbits twice and the other one orbits once. And they're like factors of each other. It's really interesting the way they do that. Anyway, but they're elliptical orbits. That's where I was going with this. So the Moon travels along this path, and the Earth is at one of the foci. And again, there's another arbitrary point here. And the major and minor axes of the orbit have lengths of, and there we go. So knowing that we have the Earth and then some other point here, I will call that F for focus. E for Earth and F for focus, although both of them are foci. There is a center somewhere in here, and it is in between the Earth and the other focal point. And this distance right here is half of the major axis. Now, it doesn't matter if you drew it this way or this way. It doesn't matter whether you drew it with the horizontal being major or the vertical being major. I'm just going to go with it this way. And then this is half of the minor axis, and the Moon travels along that orbit, or any satellite travels along an elliptical orbit. But for the Moon particularly, the major axis is 768,806 kilometers, 768,806 kilometers long, which really means we can find the A value by taking half of that. So the A value, half of 768 would be, we'll do it in my head, 384,403. You want to check behind me on that? 384,403. Yes, that is correct. And then the B is going to be half of the other one. So we'll divide 2 into that, and we get 3, 8, 3, 8, 7, 3. I feel the need to check behind myself on that one. And so we now know the A and the B. Okay, yeah, I was right. We now know the A and the B, and then it says find the greater and smallest distances, the apogee and perigee, of the Earth's center to the Moon's center. Now, apogee is the greatest distance from the Moon to the Earth. And we say to the center because we kind of use that as the actual location, the point. The center of the Earth and the center of the Moon are the actual points that are moving around. So the apogee would be the furthest distance. Let's draw it on here. There it is right there. That is the apogee. So the apogee is actually A plus this other distance right here. Well, this distance is C. here's the cool thing. We can easily find that distance. And then we also have to find the perigee, which would be the shortest distance. And this would be A minus C. So let's write that stuff down. So the apogee is really A plus C, and the perigee, I feel like I'm mispronouncing that, is A minus C. So now here's the trick. What's C? I don't know. Let's find out. Let's come over here on the side and do a little bit of magic. A squared minus B squared equals C squared. Don't you dare confuse that with the Pythagorean theorem. We know A, we know B. 384,403 squared minus 383,873 squared equals C squared. We'll find out what that is. I'm not doing that in my head. There's absolutely no way. So 384,403 squared minus 383,873 squared. We'll square root that. And we get 20,178.86 kilometers. That's equal to C. And so now it's easy. As one of my college professors says, it's can of cake. So 384,403 minus C, 20178.86. We'll figure that out. You have a calculator. And then the other one is 383,873 minus 20,178.86. There we go. Truly a can of cake. Whenever we're done, we'll just put this in kilometers. Let's finish this up real fast. 384,403 minus 20,178. I'm just going to put this so we can make sure we all get the same answer. Here we go. The furthest distance that the moon and the earth will be apart from the center of the moon to the center of the earth would be 364,224 and 14/100ths of a kilometer. The shortest distance that the moon and the earth will be apart from center to center will be 363,694.14 kilometers. There we go. We found it.